So hi everyone, today we would be looking at latency and throughput as part of our next system design lesson. So we will start with a very simple example. Let's consider a water pipeline. So imagine you have a large tank of water at one end and you want to transport this water to another end. So let's take one end like this and you want to transport to another end. Now think of these two terms, latency and throughput, as part of this example. Imagine this is your pipeline and this is tank 1 and this is tank 2. Now this is the latency is like the time it takes for the first drop of water to reach to tank 2 from tank 1. So what is basically latency? This is the time it takes for the first drop of water to travel from the starting tank to the end tank. So it doesn't matter how much water is left behind that first drop. Latency is only concerned about how long it takes for the very first drop to make the journey. So think of it as the delay before the water starts flowing out on the other side. Now you can take a real life example like this. You are standing on top of this tank. Here is the tank and you are standing here. Now for you, there's a brief delay before the water comes out, especially if the pipes are long. So that delay is analogous to the word latency. Now coming to the throughput part, you can imagine this is the amount of water that can flow through the pipe in a given period of time. Imagine for this pipe, let's imagine that 1 liter of water can flow through this pipe given in a given period of time. So a wider pipe can carry obviously more water at once. Imagine there was another pipe from tank 1 to tank 2 that could carry 2 liters of water. So its throughput would be 2 liters. Now again, considering a real life example, consider two scenarios. One where you have a thin straw and you're trying to drink a glass of water, and another where you have a wide hose. Now you can drink out much water in a given time with the hose than the straw. So obviously that hose has a higher throughput. Similarly, just like we have considered these terms in a real life example of two tanks and water pipeline, we will consider now them in the life of system design in computer science. So let's move to another page and let's consider, suppose you have this server, and I will again take the example of server and client, and let's say you have this client. Now obviously from server you would be going to client, and from you are requesting some data from the database for your client. So imagine like this, you go here, you request for something and you get it back. Okay, now this is a typical client server model that we have talked about in the first video. Now when it comes to computer science, and we have already taken the example of a real life example of water pipe, I hope things are pretty simple here. The time it takes for a certain operation to complete in a system, most often this measure is a system duration, like milliseconds or seconds. So consider in this client server architecture, the amount of time it took for the server to respond back to the client. Let's say it was asking for a data through query and it takes 1 second. Now this 1 second can be considered as latency. And for latency, as you know, every system will be having different latency. You can't expect every server to respond to you with the same latency as others. So for this we can take few examples. Suppose you are extracting 1 MB of RAM, 1 MB of RAM, 1 MB from RAM. Now from RAM, this will take you 250 milliseconds. 250 milliseconds. But the same thing, taking 1 MB, not from RAM this time, but SSD. Now this time it won't be taking you 250 milliseconds. This time it would be taking you 1000 milliseconds. Similarly, things keep increasing. Suppose you are taking 1 MB from a network. Let's say you are taking it from a network. So this time it won't be 1000. This time it would be 10,000. And similarly it keep happening. Let's take an example of intercontinental. So suppose you are taking things from India to Europe. Now this is an intercontinental round trip. So let's say from India you go to Europe. So this particular would take more time obviously. So it would take you 150 000 milliseconds. So this is a typical example of the orders of magnitude that matters in latency. Now, when it comes to throughput, things are a bit different here, because in latency you can clearly see it keeps increasing according to the distance and according to the measures that are taken during the call. Now, when it comes to throughput, you can you can take an example of the water pipe itself. Suppose this is my server, and I'm making making more calls. So just like this, the number of operations that a system can handle properly per unit time is known as throughput. So for instance, this was the server. So the throughput of a server can often be measured as the requests per second. Suppose it can handle 20 recs per second. So this would be the throughput of this particular server. So you must be thinking, okay, we have the throughput, but we always want to have a good throughput. You want your server to handle more and more requests. You can handle like 40 requests at a time, 60 requests, 100 requests, just like that. How to do that? It is very simple. As you give more money to your whatever cloud service provider, for example, you are using Google Cloud for that. Let's say you are using Google Cloud. The better would be the throughput. The more money you spend on your cloud service instance, the more better throughput you get. You must have heard, let's say a startup company is there. Now its servers can only handle 50 requests per second. But whereas when the same product is launched by Google, let's say Google, that product can handle 200 rec per seconds, because they have the capability to spend more money on their servers and make them more better to respond to more and more queries at the same time. This is how pay to increase the throughputs is the only way you can increase it. So yes, that was it from my side for this video. Typical real life examples of throughput and latency and how they are implemented in system design. You guys can go and study about them in detail, how they work and why it is very important to have good latency and throughput in your systems. We will talk about them in detail, where they are used and how there is a theorem called cap theorem. Before that, we will need to study availability, which will be the next video, and consistency, and why all these things together make up the system design more and more capable of handling bigger tasks. So that was it from my side. Thank you and have a nice day.